Hello everyone, welcome to the fourth problem of the Leetcode 150. So today we're going to be doing group anagrams. So let's get right into it. So this is a Leetcode medium. So given an array of strings, strs, or strings, group the anagrams together. You can return the answer in any order. So let's look at the examples here. Well, first, if you remember the first anagram problem earlier, the Leetcode easy, you remember that an anagram basically is two words that contain the same letters, but they're just different formations. They're both the same length, but they both contain the same letters. So an example here we can grab from example one here is eat and tea. So we have eat and tea. As you can see, they both contain E, both contain A, both contain T. So these two are anagrams of each other because they both contain the same letters. So let's look at the example to get a better understanding of what this is asking from us. So you can see input strings, or strs. We have an array of strings, and the output is an array of arrays with strings inside of them. And these strings are all, so they group together all of the anagrams into arrays and return that as an array. If that makes sense to you, you're just grouping. That's why, hence the name group anagrams. So you can return the answer in any order. So the order of the groups doesn't matter as long as each group correctly contains all words that are anagrams of each other. So we understand what an anagram is now. So now what can we do? What do we start thinking about? So if you sort the letters, if you sort each letter lexicographically, again, this goes back to the first anagram problem, how we solved it. All anagrams become the same string. So look, so now you have, so let's look at the anagrams here. So we have C, A, E, and T. So if you sort these, each letter in each of these words alphabetically, you would get what? So A, E, T. If you sort every single one of these words lexicographically speaking, you get A, E, T, and that's how you know that they're anagrams. That's how we did it in the first problem. So AET here becomes a unique key that identifies all of those words belonging to the same group. So now we can think, what data structure can we use here? We could use a hash map. So we can use a hash map to group words. So the key would be the sorted version of the word, example AET. So let's go here. AET will be our key, and then our value would be the list of all words that match the key. So A, eat, and then T, if that makes sense. So now you thought about a data structure. Now it's time to implement this code actually. So now we're here. You can go here. Now let's start making the function. So now we can start. Let's make a hash map, like we said, result empty hash map. That will be our result. And now we loop through each string in strs. Remember, strs is our list of strings here, input strings. So now we can say for s and strs. Now what do you want to do here? Now remember we said we want to sort every word alphabetically. So now we can store that. We store each word in a variable. So now let's do sort s equals, and now when you call a sorted function, well, here we're going to use the sorted function. when you call the function sorted on a string, it will arrange them alphabetically, but it will return an array of characters. So let's go back and visualize this here. So if you call sorted function on, let's say, 8, it will return this in this fashion. So it will be A E T. This would be what the function would return. Thing is, we don't want that. We want the key to be a string as well, sorted string. So now what do we have to do? We have to call a join function, and we need a delimiter for this, and the delimiter will just be a space to join it. So then after the so this would become just a t what we want. So let's go back to the code. So now we need a delimiter, which would be our space joined by a space. So then you would call join dot join, and we will be joining the result, which would be the array that we get from the sorted function for sorting the string. Then now we can add this to our hash map. So now we have our hash map result at sort. As remember, sorted string is our key. Now I just realized something here. We should define this as default bits. And we are doing this because if you try appending to a key that does not exist, you will get an error. So a default bit will give us an empty string as soon as, like, if we give a key that's not in the hash map, it'll immediately create an empty list for us for the value, which is great. So that's just something to think about there. Python is really helpful in that way. So now we can append the normal string to that key as we did here, right here. This is exactly what we're doing. That's what the code does. So now we can finally just return it. Simply return. But remember, we have to return at a list of lists. So right now, the key value pair in the hash map. So now our value is just the list of groups. So now we have to group those groups into one array for the output as shown here. So now let's do that. So we have to call the list function, and then result, which is the hash map dot all of its values. We're putting them all into a list. And this should be it. And we run this. This should work. Yep, see, it works. And yeah, that's it.